problems are general problems. Okay, we have covered many problems from the previous GATE exam paper. Okay, now these problems, though they have not appeared in GATE exam paper, but these type of problems are definitely expected in GATE exam. First one, compute the DTFT, discrete time Fourier transform of sequence. Some sequence, some input signal is given, or some sequence is given, 2 multiplied by 3 by 4 to the power n u of n. You have to find the DTFT of this. After finding the DTFT also, plot magnitude response. Okay. How to solve this? See, since it is a DTFT, that means definitely it will be for a non-periodic signal, and the signal is non-periodic. You can see here. Okay. So the formula for finding DTFT is equal to summation n tending to minus infinity to infinity x of n e to the power minus j omega n. This is the formula. Replacing x of n by the given expression in the question, I can write here n equal to 0 to infinity to 3 by 4 to the n e to the power minus j omega n. I can write this expression further to n equal to 0 to infinity 3 by 4 to the power n e to the power minus j omega n. Now this is a geometric series. Okay. Whole to the power. The sum of geometric series, infinite geometric series, is 2 into 1 upon 1 minus 3 by 4 e to the power minus j omega. So this is the expression for x of omega. Simple. Now for finding the magnitude response of this, this is omega equal to 0th point. Definitely it is going to be continuous. Okay. Now this is at omega equal to 0, I will have x of 0 equal to 2 into 1 upon 1 minus 3 by 4, which is equal to 8. With increasing omega and with decreasing omega, this value will keep on decreasing. So the plot is something like this. Maximum, okay. So this is a magnitude plot of given DTFT of the sequence. Understood? This important is this formula. If we remember this formula, we can easily find the DT of the sequence. Next problem. Next problem is to find the periodicity of the signal. Determine the periodicity. Yes. Xt is equal to ut minus 1 by 2. You have to find whether this is periodic or non-periodic. I know the plot of ut is this. Tending to. If I find ut minus 1 by 2, then for t value lesser than 0, xt equal to minus 1 by 2, For t value greater than equal to 0, xt value will be 1 minus 1 by 2 equal to 1 by 2. So if I draw a plot of this, then it is something like this, minus 1 by 2 to 1 by 2. Thus, we can see from the plot itself, it is not periodic. Okay. The B part of question is, find the period of 2 sine 3n. This is sine xn. Okay. For this discrete time signal, we know the formula for finding the periodicity is omega by 2 pi is equal to k by n, and this should be a rational number. Now omega is equal to 3. So 3 by 2 pi is equal to k by n, which is not a rational number. Thus, it is not a periodic signal. Not periodic. Okay. So these were the two problems from the topic of periodicity. Third problem. Third problem is finding the convolution. Find convolution of two sequences are given. One is xn, again discrete time sequences, u of n, u of n minus 4, v of n, another sequence is given 0.5 to the power n un. We have to find convolution yn, which is equal to x of n convolve with v of n. Solution. Since it is a discrete time signal, xn is finite, vn is infinite. Okay. Now, according to the formula of convolution, I can write xn convolve with vn is equal to summation k tending to minus infinity to infinity x of k v of n minus k. Okay. So this I can write as summation k tending to minus infinity to infinity u of k minus u of k minus 4 0.5 to the power n minus k u of n minus k. Okay. So this is my net expression, which is derived from this expression. I have substituted xn in xk, v of n minus k, v of n. Okay. So these two expressions I just written in a formula. Next. Now there will be two regions. Okay. First region is for n value lying between 0 and 4. Okay. In this case, what will happen? Summation will lie from k equal to 0 to n, 0.5 to the power n minus k. Okay. On solving this, I will get 0.5 whole to the power n summation k tending to 0 to n, 0.5 whole to the power minus k. I can write this as 0.n summation k equal to 0 to n 2 to the power k. Okay. So this will be a sum of geometric series 0.5 to the power n, 1 minus 2 to the power n plus 1 upon 1 minus 2. On solving this, I can write this as minus 0.5 to the power n minus 2. Okay. So this is the solution for the range 0 less than n less than 4. Okay. Now second case in this will arise when n value greater than 4. For n value lesser than 0, yn will be, the convolution will be 0. Okay. This will exist only for two values. First, the n value lying between 0 and 4, and second, when the n value is greater than 4. In this case also there will be some geometric series, and we have to find the solution of that geometric series. So if we look in this, it is equal to summation k equal to 0 to 4, 0.5 to the power n minus k. Okay. Solving this, I will get 0.5 to the power n, 1 minus 2 to the power 5 upon 1 minus 2. So this is equal to minus 0.5 to the power n plus 0.5 to the power n minus 5. This is a solution for the convolution. Okay. So these type of problems are expected at GATE exam. We will further solve more problems. We will see now one problem from the topic of convolution. Two signals xt and ht are given. From this we need to find the yt, which is the convolution of xt and ht. Find yt is equal to xt convolve with ht. xt is given as ut, which is a unit step function. Okay. ht is given by this by t value. We have to find xt convolve with ht. Okay. Applying simple rules for finding the convolution, I'll make x of t to x of t minus tau. I'll make ht to h of tau. Okay. So when I make xt to x of t minus tau, I'll have waveform something like this. Okay. Time reverse and shifted by t. This is my x of t minus tau. Writing expression for ht, I need to find the equation of two lines. This is my line number 1, this is my line number 2. This is 2, this is 1, this is 2. Okay. So the equation for line number 1 is 2 tau. This is my h tau. Equation for line number 2 is minus 2 tau plus 4. We can find just the equation by y minus y1 equals to y2 minus y1 upon x2 minus x1, x minus x1. Okay. This will give me the equation of both the lines. Now we got h tau, we got x of t minus tau. Now we have to use the formula of finding the convolution. Now there will be several cases. Okay. Several cases in the sense, case when x of t minus tau has not touched h tau. Okay. In that case my t value will be lesser than 0. So I can write the first case for t value lesser than 0. In this case there will be no overlap. Thus yt is going to be 0. Okay. Now second case. Second case is when t value is lying between 0 and 1. In this case it is something like this. Overlap region. This is t, this is 0, this is 1, this is 2, this is 2 and this is 1. In this case I can find my yt, which is equal to 0 to t 1 dot 2 tau d tau. So this is equal to 2 tau square by 2, 0 to t is equal to tau square 0 to t, which is equal to t square. Okay, this is the expression for this range. Next, a third case will arise, which is for t value lying between 2. So if I draw a diagram for this case, it will be something like this. See, this value is 2, this value is 1, this is 1, this is 2. So then this is my total overlap. So now there will be two regions of overlap. One region of overlap is this. Okay. Another region of overlap is this. Mark this as 1, mark this as 2. So for two region of overlap, there will be two separate integrals. I can write my yt, which is from 0 to 1. Equation of this line is 2 tau d tau. Okay. Next integral will be from 1 to t minus 2 tau plus 4. This is the equation of this line. Okay. For solving this integral again, 2 tau square by 2, 0 to 1 plus minus 2 tau square by 2 plus 4 tau 1 to t. This is equal to 1 minus t square plus 4t plus 1 minus 4. Okay. So this is equal to minus 2 minus t square plus 4t. This is my yt for second case. Okay. So understood. The first case when t value is lesser than 0. Second case when t value is lying between 0 and 1. Third case when t value is lying between 1 and 2. Now there will be fourth case, which is for t value greater than 2. Okay. We'll see that case. Fourth case when t value is greater than 2. In this case it will happen something like this. There will be complete overlap. Region 1, region 2. 1 and 2. Point is 1, this is 1, this is 2. Okay. Now yt in this case is equal to 0 to 1. I have to integrate with respect to 2 tau d tau, and 1 to 2 I have to integrate with respect to minus 2 tau plus 4 d tau. So this is again 2 tau square by 2, 0 to 1 plus minus 2 tau square by 2 plus 4 tau 1 to 2. Solving this integral, I will get as 2. Okay. So this is, after this it will remain permanently constant. So to summarize, I can write my yt as 0 for t value lesser than 0, t square for 0 less than equal to t less than 1, minus t square plus 4t minus 2 for 1 less than t less than 2, and 2 for t value greater than equal to 2. So this is my overall convolution for the given xt and st. You can see this once again, clear your doubts. Okay. Next problem. Next problem will be from the topic of systems. The problem is to determine whether the following systems are time invariant, linear, causal, and oblique or memoryless. There will be several equations describing the system. From those equations, I have to define whether it is linear or time invariant or causal or non-causal, memory or memoryless. The first one is dyt by dt plus 6yt equals to 4xt. I have to find whether this is the type linear or non-linear, time variant, time invariant, causal or non-causal, memory is memoryless. See, the given differential equation is ordinary differential equation. Ordinary differential equation, and that too the coefficients are constant coefficients. Okay. The differential parameter d by dt which is coming into the picture, it is because of some memory component present in this. So definitely it is a memory system. Since the coefficients are constant, it is linear. Okay. It is causal because it never depends on the future values of the input. Okay. The remaining is time variant or time invariant. This is time invariant because the coefficients are constant coefficients and none of the input and output are related by a function of time. Second one, yn plus 2 times of y of n minus 1 equal to x of n plus 1. This earlier one was ordinary differential equation, so this is a difference equation again with constant coefficient. Difference equation with constant coefficient. Okay, so it is linear, time invariant. Okay, it is non-causal because x of n plus 1. It is memory. Next one, yn equals to n dot x of 2n. Now in this equation, output and input are related by some function of time. Thus, it is time variant. It is linear, non-causal because n for n equal to 2, my x will be 4. That means I am anticipating the output. Memory element is present. Okay. One more is left. Fourth one, dyt by dt plus sin t yt is equal to 4xt. This is differential equation but not with constant coefficient. So this one is linear, time varying, causal, and has memory. Memory element present in differential equation, physically it is due to presence of inductance and capacitance. Okay. So these are the 4 different types of systems and their system properties we can determine by mathematically analyzing this equation. Okay. Third problem. a system is given in which input is xt, output is yt, and this is xt. When xt is ut, output is 1 minus e to the power minus 2t. Determine the output when xt is equal to 4 ut minus 4 u of t minus 1. Okay. See, solution. We need not to find the impulse response in this problem. Okay. See, if ut is giving me 1 minus e to the power minus 2t, then u of t minus 1 will give me, this is LTI system. U of t minus give me 1 minus e to the power minus 2 of t minus 1. Why? Because of LTI system. Shift in input produces same shift in the output. So ut minus u of t minus 1, again use the linearity property, 1 minus 2t minus 1 minus e to the power minus 2 t minus 1. Okay. 4 times of ut minus 4 times of u of t minus 1 will produce 4 times of 1 minus e to the power minus 2t minus 4 times of 1 minus e to the power minus 2 t minus 1. So this is a solution, or this is a response to the given input which is asked in the question. So these are the few typical problems which are quite expected in GATE exam. Okay. We will discuss some important points which are asked in the form of 1 mark question from the topic of signals and systems. Okay. So the heading of this is important points. Okay. The first one is, for a given time domain signal, what will be its frequency domain representation? Okay. So time domain signal can be of different types, like continuous time, periodic, continuous time, non-periodic, discrete time periodic, and discrete time non-periodic. So we'll see the time domain and their frequency domain characteristic. It will be called by a different name in frequency domain. First one. First is continuous time periodic. It will possess Fourier series. Okay. That Fourier series will be non-periodic. Okay. Remember that Fourier series is non-periodic for continuous time periodic signal. Next is, this is called CTFS, continuous time Fourier series. Second one is continuous time non-periodic signal. This will have Fourier transform. Again, this is non-periodic. This is called CTFT. Okay. Third one is discrete time periodic signal. This will possess Fourier series. but this time the Fourier series will be periodic. This is called DTFS, discrete time Fourier series. Fourth is discrete time non-periodic. To this, it will possess Fourier transform. This is again periodic. It is called DTFT, discrete time Fourier transform. Okay, so sometime in GATE exam it has asked us a match the following type of question. Okay, so this was one important point which we should know. Second one. Second important point is, for a particular type of time domain signal, that means whether signal is real or signal is imaginary, signal is odd or signal is even, or it is a combination of real and odd or real or even, how the Fourier transform will be. What is the type of Fourier transform? That means whether it will be also real or it will also be real or imaginary, real and imaginary, once it is real and even, real and odd, or any kind. Okay, so there are different types. Again, I'll write time domain, counterpart, and frequency domain. Okay, first, if in time domain signal is real, then in frequency domain it will be conjugate symmetric. Okay, in time domain, if signal is imaginary, then it is conjugate antisymmetric. If it is real and even in time domain, then frequency domain also it will be real and even. Okay. Fourth is, if it is real and odd, then in frequency domain it will be imaginary and odd. That means if signal is odd in time domain, it will make frequency domain imaginary and odd. Similarly, if it is imaginary and even, it will be frequency domain also it will be imaginary and even. If it is imaginary and odd, then in frequency domain it will be real and odd. That means if signal is odd, it will make real signal imaginary, if an imaginary signal real in frequency domain. Okay, so these can also come as a 1 mark question in GATE exam. Okay, so this is important point number 2. Now there is one question which has appeared in GATE 1994. I'll just write or just explain the statement what this question wants to say. If signal is given, a non-periodic signal, continuous time by e to the power minus 80. Okay. Now this signal is applied as an input of low pass filter. For the low pass filter, magnitude response is given by b under root omega square plus b square. Okay. Now we have to calculate ratio a by b, for which 50% of the input signal energy is transferred to output. Okay, so this is the question. Solution. See, ft is given as e to the power minus at ut. If I want to find the Fourier transform of ft, it will be 1 upon a plus j omega. Okay. Now, the spectrum energy density of the input is equal to 1 upon a square plus omega square. Okay. We know that output energy density h omega filters magnitude response square input. Okay. Now output energy density will be b square upon omega square plus b square upon 1 by a square plus omega square. Okay. This is my SIY. According to the condition given in the question, minus infinity to infinity SYY d omega energy in this is SYY is energy density spectrum, so total minus infinity to infinity if I integrate with respect to frequency omega, then I'll get the energy. This should be equal to half of the input signal energy. Okay, so I can write this as integral of minus infinity to infinity b square upon omega square plus b square 1 upon a square plus omega square d omega equal to 1 by 2 minus infinity to infinity 1 by a square plus omega square d omega. Okay. Now this integral can be solved by substituting omega with b tan omega. Okay. So after solving this integral, I will get on the left hand side is pi b square upon ab a plus b, and on the right hand side, left hand side 2a. This will give me ratio a equal to b, or ratio of a by b equal to 1. So this way this problem is solved. Yes, it is true that solving this integral needs prior knowledge how to solve this. Okay, but if we know that, we can solve it and we can get the answer. Okay. Or otherwise, what could be the solution? What could be the other solution in case if we don't know the integral? The solution is, if the options whatever given in the question, we can use those options back and substitute in this integral and see for which options this integral is satisfied. Whatever option this integral is satisfying, that will be the answer. Okay. So this completes one more session for problems related to